Okay, today we're talking about polynomial functions. First, let's talk about what a monomial is. It can be a number, a variable, or a product. So like 2x is a monomial. The degree is the degree of the variable. So like in this case, this one is, because the x is to the first degree, this is a first degree, or degree equals 1 monomial. So if we had something like negative 3x to the fourth, so that would be the degree equals 4, fourth degree. Even like a number, what's interesting is like 2x is first degree. The number 2 is actually degree equals 0. So like if it's just a constant, it doesn't really have an exponent. If it did have an exponent, it'd be x to the 0 power, because x to the 0 power is 1. But a degree is 0 of just a constant there. So that could happen. And then there's like a polynomial, which means many. So there could be, more. So like if you have something like 3x squared minus 4x plus 7, the degree of that polynomial is 2, because the largest degree, this 7 term is degree 0. The 4x term, negative 4x, is degree 1, because x is to the first, and then 3x squared is to degree 2. So it's a degree 2 polynomial. We would call it a quadratic. That's what we typically call a degree 2 polynomial. Okay, so let's talk about different types of polynomials here. So first, let's talk about a constant function. So if we get our calculator out, so if I type in the function y equals 3, or f of x equals 3, so just press 3 and press enter, that's a horizontal line. So that's called a constant function. So the degree of a constant function, let me keep that so it stays up there. So the degree of a constant function, the degree equals 0. The graph might look like, it's going to be a horizontal type line here on there. And, a function might be something like y equals, 2 or 3 or something. That's going to be the form of this. And you can see there's no real variable on the right-hand side. There's no x variable there. And that's a type of polynomial that's called a constant function. So linear function, you're very familiar with. The degree of a linear function is 1. If you looked at a graph of a linear function, it's going to have, it's going to be a slanted line. This one has a positive slope. If I double click this and change it, let's make it like a negative 1/2, oops, 1/2 x plus 1. So there's a linear function, right? It has a negative slope, this one does. And so it's going to be like, something like y equals mx plus b would be the form of the problem, like y equals mx plus b. It's a linear function, so it's going to be a graph of a straight line with a positive or negative slope. So quadratic has degree 2. If you look at a quadratic graph, you probably have seen enough of those this year to know that this is going to be some type of parabola. And so you're going to have like y equals, x squared, could be plus 2x plus 1 or something. The main thing is this is a second degree, because the largest degree term is to the second power. So x to the second power. Doesn't really matter what I put here, minus x, minus 1. It's going to be a parabola-shaped graph when it's degree 2, when it's a quadratic. They all have that same look. And so some of these we're not as familiar with. So maybe you're pretty familiar with these three. I feel like now maybe you don't have a good comfort level with these. So if you look at this graph, it typically is going to have I mean, it could look something like this, right? Where it kind of has like a wiggle in the middle kind of a thing here. So in that case, it kind of goes back and forth. It could be something very straightforward, just like something like, let's do x to the third. So you see that graph, it has a little bit of wiggle in the middle, but it's basically, it kind of starts low, ends high. It's an x to the third graph. So again, you're going to have y equals, x to the third plus, 2x or whatever the graph is, but it's going to have, x to the third power. So when it's cubic, it's third power there. That's the key. The highest degree term is to the third power. So if it's to the fourth power, that's going to be called quartic. If you look at the graph of quartic, it may have a couple of wiggles in the middle. So it might look kind of like a W. That could happen. The equation might be, y equals x to the fourth, and then, plus 2x minus 1 or something. It doesn't have to go down by degree of 1, but that large degree term would be x to the fourth. And finally, quintic is degree 5. You don't see a ton of these, but you might. And they're going to kind of start like this. Going to have a couple of wiggles in there. Might look something like that, and that's going to be like y equals x to the fifth plus whatever, plus 5 or whatever. Okay, let's look at end behavior here. So end behavior of this graph. So the key thing with end behavior is you really want to look at the large degree of the term. So, oh, that's not really the largest degree. Oh, I did not put it in order, did I? So in this case, this is a fourth degree. That first term is third degree, last term is 0 degree, but the middle term is fourth degree. So this is a fourth degree. And so really not just, also the negative sign, that's going to affect, here we go, all of that. That term is going to affect the shape of the graph quite massively. So whatever the largest degree term is in this case, x to the fourth, is going to have a major effect on the graph. And what that's going to do, so I want you to see a pattern here. So maybe you'll see this. So I'm going to type in this. I'm going to put x to the power of a. And it should create a slider for me. It does for a. And I'm going to change the slider to minimize it. And so I want you to look for patterns here. And what we're looking at is the end behavior. So let's take x to the first. So if you look to the left, as far left as you go, it's going down forever, down and to left. If you look to the far right, it's going up and to the right forever. So the end behavior of this graph is on the left side down, on the right side up. It's going down forever on the left, and it's going up forever on the right. So it's a down-up end behavior. If you look at x squared, now when you go left, it actually is going up. When you go right, it's going up. So this is an up-up graph. So the end behavior is up and up whenever the end behavior is a degree 2. Degree 3, you can see that this starts low and ends high. So kind of like degree 1 did. So you might see some even and odd. When you go to degree 4, it starts high, ends high. So high, high. Degree 5, again, it starts low, ends high. So all the odd ones seem to have this same kind of thing. So let's make this go a little higher. Okay, even, odd, even, odd, even, odd. So it alternates. It goes up, up, down, up, 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 down, up. So that's always going to be the case. Now, if you put a negative in front of the function, so let's put a negative in front and see how this changes. So when x is odd, oh, now it starts high, ends low. If I go down to x squared, it goes low, low instead of high, high. Now it starts high, ends low. So just everything's the opposite. When you have a negative attached, it's exactly the opposite. The odd ones always, in this case, when it's negative and odd. So there's really 4 cases I need you to be aware of. Let's talk about those 4 cases. So we'll come back to that in just a second. So I want you to be aware, super aware of these four cases. So let's look at these four. So if you have the first case, and I always like to think about the ones I know. So let's say you have a function like y equals x squared, because hopefully you know that graph pretty well. So there's two things I'm going to say about that exponent here. So it's this one is even, it's an even exponent, and there's no negative right here. So this one is, I'm going to say it's positive. So the graph of this one, when it's even and positive, will always be, I don't know what the parabola looks like, but it's going to be up and up. So the parabola will start up on the left, and as it goes to the right forever, it's going to end up as well. Again, I'm just writing the first term. There could be more terms to this one. So I'm going to write the first term here. So y equals x to the third. It could plus blah, 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 blah. The rest of the numbers are smaller. So x squared, x constant, etc. So that first term is going to determine the shape of this graph. And so when you see that, the shape of this graph is going to start as kind of your classic odd graph. It's going to start low. It might have a wiggle in the middle, but it's going to end high. So it might have one kind of wiggle in there, but it's going to start. So I'm going to write this. This one is low, high. Whereas this one is high, high, if you just kind of want to write it in words. Starts high, ends high. So let's go to another case here would be, let's say you have something like this, y equals negative x to the fourth. So now, it's a 4 right there. So now we have an even exponent. Like this one was an odd exponent, but positive. Those always are low, high. Even exponent, but negative. So even and negative is going to be high, low. So it might have a wiggle in the middle, but it's going to start high and end low, which is the opposite of this one that starts low and ends high. And the last case that I need you to know is y equals negative, say, x to the fifth. Again, could be plus blah, blah, blah. The big key there is that's the largest degree term. And so when this is odd and this is negative, so that case, it's always going to, I'm sorry, I drew this wrong, didn't I? So let me redo this one. Helps to do the notes correctly so you have the correct cases. So even, you're going to take this graph and it basically just flips. So it's going to be high, it's going to be low, low for this one. So low, low. Because what does a negative do to a function? It reflects it over the x-axis, right? So this is going to start low and end low on the left and on the right here. Whereas this one, when it's negative and odd, it's the opposite of positive odd, which is low, high. So it's going to be high, low. So it starts high. On the left, it starts high. On the right, it ends low. So those are really the four cases you have to know. This is called end behavior. It's end behavior because we're talking about at the extremes. We're talking about if you were to graph, and as you look to the very rightmost part of the graph and the leftmost point, it's either going as high as it can or going as low as can in one of those directions. So the end behavior, this one is negative and odd. Negative and odd. So it's going to start high and end low. So the graph might look something like this. This one, the largest degree term is negative and odd. Negative and even. Why do I keep messing that one up? I'm so sorry. So this one is, when it's negative and even, it's going to be down, down. Just pay attention. When it's negative and odd, that's the opposite. So I call this like a left-handed John Travolta. So if you think about, staying alive. So this starts high, and then it's going to get low. So the graph may look something like this, kind of like we just did when I did it incorrectly. This one, the largest degree term is this one, so that's negative and even. That's going to look like this. That's going to be low, low, or down, down, however you want to say it. You can use down, down, up, up, low, low, high, high. It doesn't matter to me. X to the first, so that's odd and positive. So that's going to start low and high, calling it classic John Travolta. So that's going to be low, high. This one, this is the large degree term. It's even and positive. So up, up, or high, high. This one is odd and negative, so like that. So this can be up, down. And this one is odd and positive, so it's going to be down, up, the opposite of that last one. And I think you're getting the idea here. So end behavior is something that's going to help us a lot coming up when we're trying to graph functions without our calculators. And so I think for tonight's homework, it's mostly about end behavior when you get there. So have fun. That's your lesson for today.